We are going to apply the row operation elements to the different rows of this matrix, so that we have to create a matrix which is which has all zeros below the diagonal element. So this is the diagonal element 6 minus 8, 9 and 18, and all of these elements are the below the diagonal elements. So we have to create this element to the 0. So that is an objective. What we have to 0? We have to create these elements to the 0. How can we create these elements to the 0? This 0 can be made by, if I multiply 6 by 2, this becomes 12. And then subtracting row number 1 from row number 2. So I will write down this operation as R2 R2 minus 2 times of R1. So R2, 2 times of R1 will be subtracted from R2. So this becomes 0 because this is 6. When I multiply this 6 by 2, this becomes 12. 12 minus 12 becomes 0. So we will have 0 here. Whatever we will have here doesn't matter, but it should be 0. Now in the second step, we have to make this to be 0 and this to be 0. Acha, one more thing we can do, and that thing is we can create this row to the 1. Initially this is to be 1. If I am doing to make it to the 1, so there is no need to multiply it by 2. So instead of multiplying by 2, I am going to, or dividing the row number 1 by 6. So by dividing the row number 1 by 6, we will have 1. So both options are correct. Either we can subtract directly by multiplying 2, or by R1 is equal to R1 by 6. So after that, what we will have? We will have 1 here. And if it is 1, then this step becomes 1. Firstly, you have to write down one. I skipped one step that should be done before going to start this row operation process, and that step is we have an augmented matrix. We have to create augmented matrix. So what is to be do in augmented matrix? Only this vector A and the B is to be write down. Only the A and B is to be write down. This matrix is called augmented matrix. So in augmented matrix we have 6, 12, 3, minus 6, minus 2, minus 8, minus 13, 4, 2, 6, 9, 1, 4, 10, 3, minus 18, and we have a vertical line here, and B is to be write down 16, 26, minus 19, minus 34. So this is the first step number 1, in which we have to write down the augmented matrix. Now I want to create 1 here. So my row number 1 divided by 6. Row number 1 divided by 6. So what do we have? 1 minus 2 by 6 and 2 by 6, or 1 by 3 we can write down. It will be the 4 by 6. It will be the 16 by 6. The rest of the elements will be as it is. So this is 12, this is -8, this is 6, this is 10, this is 26, 3, -13, 9, 3, -19. Then we have -6, 4, 1, -18, and -3. What will be the next step? We have to make it to the 0. This is to be 0. This is to be 0. These three elements simultaneously, we can make these three elements to the 0. The 3 row operations are required. R2, R2 minus 12 R1. Then R3 minus 3R1. And the next element will be R4 minus, this will be the plus 6R1. Because if it is 6 and I will add this 6 into -6, so this will be 0. So after these 3 row operations, these 3 elements become 0. So I can write down directly here 1, 0, 0, 0. Because these 3 elements become 0 after this. There will be no change in row number 1. So I can write down the row number 1 directly according to that, minus 1 by 3. This is 1 by 3. This will be the 2 by 3. And this will be 8 by 3. This is the row number 1. There is no change in row number 1. Now this will be changed. So how can I calculate the number here? It's quite simple. -8 minus 12 times R1. Here we have -2 by 6. So minus 1 by 3, or we can say it is -1 by 3. Because -2 by 6 basically is -1 by 3. 3 4s are 12. This will be the plus, and this is -8. This is -4, -8 is -4. So I will have -4 here. And this will becomes, here we have -13. I am calculating this one first. 6 minus 12 and 1 by 3. So this is 4. 6 minus 4 becomes 2. So this will be 2 here. Now 10 minus 2 by 3 times 6 minus 12 times 12 times and 4 by 6. 12 times 4 by 6. So this is what? This is, and again this is 10 minus. So 6 2s are 12, 4 2s are 8, 10 minus 8, 10 minus 8 is equal to 2. So this is equal to 2. Now the last one is what? Last one is 26 minus 12 times 8 by 3. So this is 3 4s are 12. So 4 by 8 and 26 minus, it is 32. 26 minus 32 minus 6. So I have minus 6 here. So this is the row number 1 after some row operations. Step is R2 divided by minus 4. There will be no change in row number 1. There will be no change in row number 3 and 4. Only the row number 2 will be changed. So I am just copying row number 1, 1, minus 1 by 3, plus 1 by 3, plus 2 by 3, plus 8 by 3. This will becomes, this is 0 already. This will becomes 1. 2 by minus 4 becomes minus half. 2 by minus 4 becomes again minus half. And 6 by 4 becomes 3 by 2. The remaining rows will be same. 0, minus 12, 8, 1, minus 27, 0, 2, 3, minus 14 and 13. What will be the next step? In the next step, we have to make this 0 and this 0. These two will become 0. How they can make these two zeros? So multiply this row number 2 by 12 and add it into the row number 3. So we have to make the two operations. One is row 2 will be changed. And how row 2 will be changed? Row 2 minus plus 12 times row 3. Now, no, this will be the row 3 which is changed. Row 3 plus 12 times row number 2. And row 4 will be changed by row 4 minus 2 times row 2. Row 4, 2 times of row 2. So after these two operations, row number 1 will not be changed. 1 minus 1 by 3, 1 by 3, 2 by 3, and 8 by 3. This is same. Row 2 will also be same. 0, 1, minus 1 by 2, minus 1 by 2, and 3 by 2. And row 3 and row 4 will be changed. What change will be there? This will be the 0 and I think I made some error. No error there. Now you have to calculate these elements. This is and this is 1. We have to make these two zeros. So this will become 0 and this will become 0. This is already 0. This is, here we have to calculate the numbers. So these numbers are to be calculated by these two equations. So similarly, the girls can calculate the row number 1 row number 3, and boys can calculate the row number 4. I am pausing the recording and giving you the time to calculate. And the next step is to make this third row first third row first non-zero element to 1. So we have to divide row number 3 by 2 so that this element will becomes 1. So here we will have 1, here we will have 1, this will becomes minus 9 by 2. So the next step is row 3 is equal to row 3 divided by 2. So this is to be carried out to the next slide. So in the next slide, we have all of these elements to be there. So you have to tell me what are these other steps. You have to subtract 4 times of row 3 from row number 4. So row number 1 remains same, 5 by 3. Row number 2 remains same, 0, 1, minus half, 3 by 2. Row number 3 remains same, 0, 0, 1, 1, minus 9 by 2. This will be same, 0, 0. Now you have to calculate these 3 elements by this operation. So just calculate all these 3 operations and tell me the answer. In the next step, we have to make it to the 1. But this is not necessary step. Again, for similarity purpose, all the diagonal elements will be 1. So we have to divide the last row by minus 17. So if I divide the last row by minus 17, this step becomes R4 divided by minus 1 by 17, minus 17. So I'm just changing these two elements. This will becomes 1 and 28 divided by minus 17. So this will become 28 divided by minus 17. And we have a vertical line here because this is an augmented matrix. The augmented matrix, we have first step has been completed. That was forward elimination. This was the first step. In the first step, we have to make all of these diagonal elements to the 1 and the lower diagonal matrix or the lower triangular matrix to be 0. After completing the forward elimination, we have to use backward substitution. What is the process of backward substitution? In the backward substitution, we have to use the last row. So if I multiply the last row, 0 multiply by x1, 0 multiply by x2, plus 0 multiply by x3, plus 1 multiply by x4 is equal to this number. So we can simply call it as x4 is equal to 28 by minus 17. This is the first value of x4. Now, if I multiply 0x1 plus 0x2 plus 1x3, 1x3 means the x3, x3 and then plus x4 because this is 1x4. So x3 plus x4 and then we will have what? Is equal to this is equal to minus 9 by 2. Now substitute the value of x4. This is already we have. So x3 plus 28 by minus 17. So we can, instead of plus sign, we have a minus sign here. It is equal to minus 9 by 2. We have to solve x3 by x3 is equal to minus 9 by 2 plus 28 by 17. So 17 multiplied by 2 will be the LCM, 34. 9 to the 9 multiplied by 17. How much is it? 9 multiplied by 17 plus 28 multiplied by 2. It is 56. So what is the value of x3? Can you tell me the value of x3? 0x1 plus 1x2 minus half x3 minus half x4 is equal to 3 by 2. Already we have the value of x2 and x3 here. Value of x4 and x3 here. To put the value of x4 in this equation and put the value of x3 again in this equation, so we will have the value of x2. So x2 is equal to how much? You can calculate the value of x2. In the same way, you have to use equation number 1. In equation number 1, we have x1. 1x1 is x1 minus 1 by 3 x2 plus 1 by 3 x3 plus 2 by 3 x4 is equal to 5 by 3. Now put all of the x2, x3 and x4 into this equation, you will get x1. So the value of x1 will be obtained in this way. So this method is known as the backward substitution. And the first step was known as forward elimination. After these two steps, we have the solution of the entire system. The value of x1 we will have, the value of x2 we will have, the value of x3 we will have, and value of x4 we will have. After calculating all these x1, x2, x3, and x4, we can verify whether these calculated results are true or not. These results can be verified by substituting these numbers into the given equations. So what were the given equations? These were the given equations. If we substitute the value of x1, x2, x3, and x4, the system will be verified. Unfortunately, these numbers are not looking as the correct answers because I think there are some errors in the calculation so that the coefficients are not true. So the solution of the entire system is already recorded and available into the presentation. You can check that how these zeros are here and what are the changes we need to make the augmented matrix to the lower triangular matrix. So after making these lower triangular matrix, we have system of equation minus 3x4 is equal to minus 3. That will becomes 1. And x2 becomes again 1, and x3 becomes minus 2. And so you can verify and rectify the corrections in my solution by looking at this already available solution into the presentation. So that is the end of this complete working. And even though you can use Excel to follow these steps. Now we are going to discuss the algorithmic representation of this entire procedure. So because this procedure is iterative, whatever we are doing is the same type of work. So we can make an algorithm. What the algorithm is? This is the algorithm. The aij is computed by aij minus ai1 divided by a11 multiplied by a1j. So this number, this is the factor which we are going to calculate. This factor is to be multiplied by the all element of the row number 1 and then subtracted to the corresponding elements. After the subtraction, we will have, so after this calculation, one element becomes 0. And this is the calculation which is in the vector B. So this calculation will also be calculated, um, and uh, this can be verified by putting the matrix here. You can have these two generalized steps. One step is known as forward elimination. Forward elimination can be done by using this element of the matrix. This is the kth row of the element. The kth row can be calculated in this way. If the value of k is 1, so we have to start from 2 to n. Means we are going to calculate the row number 2 because row number 1 will not be changed. If k is equal to 2, so we have to start from 3 to n, means row number 3 to row number n will be changed, and so on. So this step is known as the forward elimination. In one iterative steps, we can show this entire procedure by this line. And backward elimination, backward substitution is, this is the generalized formula for backward substitution. So you have to keep different steps here, and these steps will be accumulated here, and the value of xi will be calculated. You have to implement these two steps in the form of algorithm. You can write the algorithm either in MATLAB or Python, and one of the languages are R programming. So any one of these three languages can be used to implement the algorithm. So in algorithm, input A is the coefficient matrix, input B is the vector of constant. These two, one matrix and one vector is to be inputted. And after inputtings, you have to calculate forward elimination by this step. This is a loop. This loop starts from k is equal to 1 to n. If k is 1, then this is row number 2 to n. If k is 2, this will be row number 3 to n. This step is to be implemented in a loop. That loop starts from 1 to n. And backward substitution is also, we need a loop here. Loop starts from where? Row number 1, if we are going to calculate the last element. Row number 2, 3, 4, 5. As many rows we have, suppose we have the 4 rows in the previous example, so this element is uh, to be coded into a single loop. That loop start from 1 to n. As many elements do we have. So this loop will be executed for the calculations of the different element of. We can also do that. In one loop, we have to embed these two steps. The same step, this one, and this step. We can embed these two steps in one loop. So it's totally depend on your logic, what type of logic you are using. Most preferably, you can have the two independent loop for both of the two steps, so that the elimination procedure is to be done first, and after completing the elimination procedure, we can implement the backward substitution procedure to find out the different values of variable. After getting all values of the variable, we have the solution of this system. We have to type the numbers here. 6 -2, 2, 4, and 16. Then 12, -8, 6, 10, 26. 3, -13, 9, 3.
Sir?
-19. After in the initial stage, I am just copying the entire matrix here and want to enforce this step at row number 2. So what was the formula? The formula was uh, Aij minus, just keep I and j to the 1 and 2. Suppose we have some numbers which are already zeros. These are the two steps, and one complete example is solved. Unique solution, we already do that. This code is already written here. Algorithmic code is there. The formula for forward elimination and the formula for the backward substitution. So the code is already written here. You have to just verify that whether the code is working fine or it is not working fine. So you have the loops are already written there, and the formula has been implemented for factor B as well as for the matrix A. Gaussian elimination scaled partial pivoting. Partial pivoting is a problem whenever the first element, which is already be 0. So if the first element is already be 0, and we are going to make this element to 1, so we cannot make this element to 1. So in partial pivoting, what we have to do, we have to just interchange the rows before going to start the Gaussian elimination. So row number 1 can be changed to the row number 2. If we change the row number 1 and row number 2, so then we will have 1 here and 0 here. So this will give us a better solution. So in partial pivoting, the step is solve the following system using Gaussian elimination with the scale partial pivoting. So you have to do what? You have to disregard the sign, find the largest magnitude of the first column. It is 5. So interchange row number 1 and row number 5. Row number 3, sorry. So 5 will becomes here and 1 will becomes here. So this step is known is an additional step. This step, what this step ensure that if we have sometime 0 in the element, that by changing the rows, that 0 will be the second element and the first element becomes 1. तो ये प्रॉब्लम जो इसमें आ रहा है ये रिमूव हो जाएगा. ये आपका यहाँ 0 आ रहा है, यहाँ 1 आ रहा है. ये 1 अगर मैं एक्सचेंज करूंगा तो we will have a 1 here and a 0 here. So the partial pivoting gives us a better solution if we have already some zeros. So that zeros can be moved to the bottom rows by partial pivoting. Otherwise, the entire procedure is same. After partial pivoting, we have to implement the naive Gaussian procedure on the matrices in the same way as we were doing. And the last is the Gauss-Jordan method. In the Gauss-Jordan method, one additional step is there, and that additional step is what? Instead of making the lower triangular, we are making the overall identity matrix. So we were making 1, 1, 1, and these were not non-zero elements. But in Gauss-Jordan method, we have to make it completely unity, identity. After making it completely identity by row operation method, the final answer we will have. So there is no need of the backward substitution in Gauss-Jordan method. Why? because direct value of x3 we will have. Direct value of x3 is 1, x2 is 2, and x1 is 1, because these elements are 0. So Gauss-Jordan is the same method as the Gaussian elimination. Instead of making the lower triangular, we are going to make it as a completely identity matrix. After making the complete identity matrix, all of the remaining bottom elements are 0, the top element is 0. One step of backward substitution is not required. In only one step, we can have the solution. That is the end of this presentation. If some of you have questions,